In this video, I'm going to talk about the solution of non-homogeneous linear differential equations. Now, how do we know if a differential equation is non-homogeneous linear differential equations with constant coefficient? So this is the form of that DE, where you have a function of x at the right-hand side of the equation, represented by r of x. Now, this f of d of y is a linear differential operator. So sometimes it's represented by other notations such as prime notation. But in this case, since we are dealing with the nth order differential equation, so it's better to represent the derivatives in terms of the linear d operator. And if y sub c is the solution of the homogeneous equation, taking note that the linear d operator equal to 0 is a homogeneous equation, and let y sub b be any particular solution of r of x, the function of x at the right-hand side of the equation equal to 0, then the general solution of the non-homogeneous equation is y equals y sub c plus y sub b. Now, there are several methods for us to be able to obtain the solution of a non-homogeneous equation. And the most useful and actual working technique is by using the method called equating coefficients, or the method of undetermined coefficients. Now I'm going to explain to you the steps on how to solve non-homogeneous equation using this method. So first step, so you are to form the complementary solution, or y sub c, by solving, of course, f of d of y equal to 0. So you deal with the left-hand side of the equation. And second, to get the particular solution, y sub b, we analyze the right-hand side of the equation, or the r of x. Now, so if r of x is a function of e raised to ax, where a is a constant, so this is how you write y sub b. So y sub b equals uppercase letter a times e raised to ax. Now, if there are several terms, so you can put another uppercase letter to represent one of the constants to be determined. Now, if r of x is a function of sine of ax, or you can see there cosine of ax, you can write y sub b equal to a cosine of ax plus b sine of ax. It means that from the root of the auxiliary equation, okay, we have an imaginary root for that. Now for letter C, if the r of x is equal to a sub 1 plus a sub 2x plus a sub 3 x squared and so on, so we write y sub b equal to this following terms. Okay, it means that it comes from a repeating root. And then the third step is to substitute y sub b and its corresponding derivatives in the given equation and solve for the values of the coefficients by equating coefficients of like powers. So I will have some examples for this one to be able to be familiar with these steps. Number 4, if the elements in y sub b has a similar term in y sub c, we multiply y sub b by x or x squared until there are no similar elements in y sub c and y sub b. Okay, so we have again another example for this one. And the general solution, please take note, of the non-homogeneous equation, non-homogeneous linear differential equation with constant coefficient is y equals y sub c, or the complementary solution, plus y sub b, the particular solution. Now let's move on to solving some of the examples. Solve the equation y double prime minus 5y prime plus 4y equals 3e raised to 6x. So this equation is a non-homogeneous equation since you have a function of x at the right-hand side of the equation. Now, how to solve this equation? So first, we need to form y sub c, or the complementary solution. So we can get that complementary solution by dealing with the left-hand side of the equation. So firstly, I'm going to write this equation into a d operator, or you may need not to write in the operator for as long as you know how to um, express its auxiliary equation, because in finding for the solution of a homogeneous equation, we need to determine the roots of the auxiliary equation. So here we'll be dealing with the left-hand side of the equation, and the auxiliary equation for this equation is m squared minus 5m plus 4 equal to 0. So we just replaced d by m. And after this, we are going to determine the roots by factoring this given equation. So we have the factors m minus 1 and m minus 4. So from these factors, we can say that m is equal to 1, and the other root is m equal to positive 4. Now from these roots, we can say that the roots are distinct, real roots. So the solution for this one is c sub 1 e raised to x plus c sub 2 e raised to 4x. So e raised to x, we have utilized the root 1, and e raised to 4x, we have utilized the root 4. So this is the complementary solution, part of our general solution for non-homogeneous equation. So we label this as y sub c. Okay, now the next step is for us to be able to determine y sub b, or the particular solution. So we use the right-hand side of the equation. This is 3 e raised to 6x. So we analyze this by, of course, observing what root is appropriate for this particular solution, since we already utilized m as the root of the left-hand side of the equation. So we'll be using m prime to represent the root of the right-hand side of the equation. So here, by looking at the exponential function, so we have 6. So the root is 6. And the solution y sub b is equal to, instead of using arbitrary constants u, so we use a different letter to represent the constant that will be determined later. So this will be a e raised to 6x, since we only have one root for this particular solution. Okay, so now we are going to utilize the given equation. So y sub b must satisfy the given equation y double prime minus 5y prime plus 4y equal to 3 e raised to 6x. So now we are going to replace y prime by y prime sub b, and y double prime by y double prime sub b. So it means that we are to differentiate y sub b and plug in the results later. So y sub b equal to a e raised to 6x. The derivative of that is 6 times a e raised to 6x. And again, we need y double prime sub b, so we differentiate again. So y double prime sub b equal to, so 6 times 6, you have 36 times a times e raised to positive 6x. Now we plug in the resulting values of y sub b, y prime sub b, and y double prime sub b in the given equation here. So plug it in here, and then combining like terms. So we have on the left-hand side 36 minus 30 plus 4. We have 10a times e raised to 6x equal to 3 e raised to 6x. Now we can be able to determine the value of a, which is, so canceling e raised to 6x, or equating the coefficients of e raised to 6x. So we have 10a equal to 3. Thus, a is equal to 3 over 10. Now that we have the value of a, we plug in the value of a in the given y sub b. So y sub b now is equal to, okay, let me pause for a moment and edit something. Okay, so I have now edited y sub b being 3 over 10 e raised to 6x. So now we plug into this general solution. So y is equal to y sub c plus y sub b. We have y sub c equal to c sub 1 e raised to x plus c sub 2 e raised to 4x plus the y sub b, which is 3 over 10 times e raised to 6x. So this is the final answer for the given equation. Solve the equation y double prime plus 4y equals sine 3x. First thing that we need to do is to form the complementary solution, which is a y sub c. So we can only do that by dealing with the left member of the equation. So we first write the auxiliary equation, and that is m squared plus 4 equal to 0. So having this equation, we can determine its root, and that is an imaginary root, so plus and minus 2i. So we don't have a real part for this complex number, just the imaginary part, meaning we don't have an exponential function in our solution. So y sub c therefore is equal to c sub 1 cosine of 2x plus c sub 2 sine of 2x. Now the next step is to analyze the right member of the equation, which is sine 3x. And sine 3x suggests that this solution is actually the result of having imaginary roots. So we can write y sub b equal to a cosine of 3x plus b sine of 3x. There's no exponential function since there's no exponential function in the given equation. Now the next step is to make sure that y sub b satisfies this given equation, which is y double prime plus 4y equal to sine 3x. So we have here y double prime, so we need to differentiate y sub b 2 times. Differentiating y sub b, we have y prime sub b equals, so a cosine of 3x, differentiate this, you copy a, differentiate cosine 3x, so we have negative 3 sine of 3x. Plus the second term is b sine 3x, so you copy b, differentiate sine 3x, so you have 3 cosine of 3x. Since we need y double prime, so we differentiate this again. So thus we have y double prime sub b equals negative 9a cosine of 3x minus 9b sine of 3x. Now we plug in these derivatives and y sub b to equation number 1. So we have y double prime sub b, which is 9a cosine 3x minus 9b sine 3x. You can see it in here. And we have plus 4. Y sub b is a cosine of 3x plus b sine 3x equal to the right member of the equation, which is sine of 3x. Now we simplify, combining like terms, resulted to negative 5a cosine of 3x because minus 9a plus 4a is negative 5a. The same here with the second term. So you have minus b or minus 9b plus 4b. So you have minus 5b sine 3x equal to sine 3x. Now we equate the coefficients. Equate the coefficients of cosine 3x. Here we have negative 5a. And the right member you have none. Therefore a is equal to 0. For sine 3x, you have negative 5b. And for the right member, you have positive 1. That's why your b is equal to negative 1 over 5. Thus, your y sub b, which is this one, is equal to 0 minus 1 over 5 sine 3x. Your general solution is y equals the value of y sub c, which is c sub 1 cosine 2x, plus c sub 2 sine 2x, plus the value of y sub b, which is minus 1 over 5 sine 3x. Solve the equation y double prime minus 5y prime minus 24y equals x cubed. So the first step is to determine y sub c, or the complementary solution. So we utilize the left member of the equation and equate that to 0 and write its auxiliary equation. So in this case, we just replace the derivative by letter m. So you have second derivative to m squared, first derivative to m. That's why we have this auxiliary equation, m squared minus 5m minus 24 equal to 0. And then the next step is to factor this to find for the roots. So the roots signify what will be the solution for the left member of the equation. Now the roots are positive 8 and minus 3. So these are real roots, distinct real roots. That's why the solution, or y sub c, is equal to c sub 1 times e raised to 8x plus c sub 2 times e raised to minus 3x. Now that we have y sub c, the next step is to obtain y sub b. So we analyze the right member of the equation. So this is x cubed. So x cubed means that the roots are repeating. So the solution should be written as, so we have y sub b equals a plus bx plus cx squared plus dx cubed. So this will be our y sub b. The next step is for us to determine these constants. But you have to make sure that y sub b should satisfy the given equation. That's why we need to determine the second derivative and the first derivative. So we differentiate y sub b. Okay, so the first derivative of y sub b is, so a is 0, differentiate bx, so just copy b, differentiate cx squared, so you have 2cx, and differentiate dx cubed, you have 3dx squared. And finally, you need to determine y double prime. So we differentiate y prime, this becomes, okay, so the first term b will be 0, the second term 2cx will become 2c, and the last term 3dx squared will be 2 times 3, so you have 6dx. And then we plug in to this given equation. So y double prime, we plug it in here. So this is 2c plus 6dx minus 5. Y prime sub b is, you have b plus 2cx plus 3dx squared minus, you have 24y sub b. So y sub b is a plus bx plus cx squared plus dx cubed equal to, you have the right member of the equation, which is x cubed. And now we arrange the given equation, okay, combining the coefficients of this particular function. So you have x cubed, you have x squared, x, and the constants. Now we equate the coefficients. For x cubed, so take a look at in the left member of the equation. So you have minus 24d is the coefficient of x cubed here. So you write minus 24d. And on the right-hand side of the equation, so you have 1 as the coefficient of x cubed. So you have equation 1. Now for the coefficient of x squared, so you have minus 24c minus 15d equal to, since there's no x squared here, so you just write 0. Now the coefficient of x, so you have minus 24b minus 10c plus 6d. Since you don't have x here, so you just write 0 at the right member of the equation. And finally, we equate the constant. So you have minus 24a minus 5b plus 2c equal to, there's no constant here, so you just write 0. Now we have 4 equations and 4 unknowns. So we determine by using your calculator, or you can do matrix. Yeah, you can determine these constants. So you have d equals negative 1 over 24. You have c equal to 5 over 192. b equals negative 49 over 2,304. And you have a equals 365 over 55,296. Now we plug in these constants to y sub b. So this is our y sub b. And for the general solution, we have, of course, y equals y sub c plus y sub b. And previously we have solved for y sub c, so we plug it in here. That's why we have this general solution. Solve the equation y double prime minus y equals 3 times e raised to x. Now writing the auxiliary equation first to solve for y sub c. So we have auxiliary equation m squared minus 1 equal to 0. So the roots are real and distinct. So you have plus or minus 1, or you have positive 1 and negative 1 as the roots for this auxiliary equation. So we can write the complementary solution, which is c sub 1 times e raised to x plus c sub 2 times e raised to minus x for this root. The next step is for us to write y sub p, okay, by analyzing the right member of the equation, since we have e raised to x and it comes from a distinct real root, so it should be a times e raised to x. Now, notice that c sub 2 e raised to 9 minus x, and for y sub b you have a e raised to x. So they have similar terms. So for that, we are going to multiply y sub b by x. Okay, so we have this particular step on the previous slide. Okay, so for as long as we do not see any similarities in y sub c and y sub b. So we multiply y sub b by x. So now we have y sub b equal to a x times e raised to x. And this should satisfy the given differential equation. Okay, and the differential equation is y double prime. So we replace y double prime by y double prime sub b minus y sub b equals 3 e raised to x. Since we have y double prime sub b, so we need to differentiate y sub b twice. So the first derivative of this y sub b is you copy the constant and you use the product rule. So x, you have x, differentiate e raised to x, so it's e raised to x, and you copy e raised to x and differentiate x, and that is 1. Now, we are going to differentiate y prime sub b. So we copy a and then differentiate the first term, so you have x e raised to x. So this is the first derivative. And then differentiate this one, so you have e raised to x, that's why you have 2 times e raised to x. So I just, proceed, I just have written here the value of, or combining, e raised to x. So this is the second derivative of y sub b. Now we plug in here. So we now have a, okay, x e raised to x plus 2 e raised to x. This is the value of y sub b minus y sub b, which is ax e raised to x equal to the right member of the equation, which is 3 e raised to x. Now we combine like terms and equate the coefficients. Okay, now combining this, so you have a x e raised to x minus ax e raised to x, so we can cancel this one. Okay, what remains here is 2 times a e raised to x. So you have here, you have the function here at the left member of the equation equal to 3 e raised to x. Now we equate the coefficients of e raised to x. That's why we have 2a equals to 3, or we have a equal to 3 over 2. Now that we have the value of a, we plug it in here in y sub b. That's why our y sub b is 3 over 2 times x e raised to x. The general solution, therefore, is y equals c sub 1 e raised to x plus c sub 2 e raised to negative x plus the value of y sub b, which is 3 halves x e raised to x. Solve the equation y double prime plus 4y equals 3 sine 2x plus 2 cosine 2x. The first thing you need to do is to solve for y sub c. So you write first the auxiliary equation of this left member of the equation. So you have m squared plus 4. So this equation suggests that the root is actually an imaginary root. So you have plus or minus 2i as the root for this auxiliary equation. Okay, now we can form our y sub c, which is c sub 1 cosine of 2x plus c sub 2 sine of 2x. Now we form y sub b by analyzing the right member of the equation. Since we have 3 sine 2x plus 2 cosine 2x, means that our y sub b is a cosine 2x plus b sine 2x. Okay, and this y sub b should satisfy the given equation, so we need to differentiate this one twice because of the second derivative here. But take note, y sub c and y sub b have similar terms. So what you will do is to multiply y sub b by x so that there's no similar terms if we compare y sub c and y sub b. Okay, that's why we have y sub b, which is, so after multiplying y sub b by x, we have ax cosine of 2x plus b sine of 2x. And then we differentiate this one. So y prime sub b is equal to, so using the product rule, so you have a, copy a, so you have a bracket here, copy x, differentiate this one, so derivative of a cosine is negative, so you have negative 2 sine of 2x, plus you copy cosine of 2x, differentiate x, and that is 1. For the second term, you have b. So you factor out b and then use the product rule. So you copy x, differentiate sine 2x, you have 2 cosine of 2x. So you copy sine 2x and differentiate x, you have 1. And then that is equal to, okay, so y prime sub b, we simplify this one. So we have 2bx plus a cosine of 2x. So we actually factored out, or we combine similar terms and factoring out, of course, the constants. So we have this equation. And then we differentiate again this equation. This becomes y double prime sub b equals, differentiate this one. Okay, so you copy first using product rule, differentiate cosine 2x, so you have minus 2 sine 2x. And plus, you copy cosine 2x and differentiate 2bx plus a, so you have 2b plus 0. Okay, need not write 0 here. Plus, you have for the second term, you copy first this factor, so b minus 2ax, differentiate sine 2x, so you have cosine 2x times 2 because of, if you are to differentiate 2x, that is 2. Plus, you copy sine 2x and then differentiate b minus 2ax, so you have 0 minus 2a, so you have minus 2a here. And then simplify, we have 4b minus 4ax cosine 2x. So take a look at here, the coefficients of cosine 2x. Okay, cosine 2x. Okay, that's why you have 4b, right? Okay, multiply this one, or you add them. So 2b plus, okay, you have minus 4, 2 times 2, so minus 4ax here. And then combining also the coefficients of sine 2x. Okay, this is your y double prime sub b. Now take note that y sub b must satisfy y double prime sub b plus 4y sub b equal to 3 sine 2x plus 2 cosine 2x. Okay, now we plug it in here. So the value of y double prime sub b is this term here, and then 4 times y sub b, which is this expression. Okay, now we combine like terms. So you have 4b cosine 2x and minus 4a x cosine 2x. So you can see you have here 4ax cosine 2x. You can cancel this one because it's minus and plus. For this term, you have negative 4bx sine 2x. Okay, and you have minus 4a sine 2x. So there's a similar term here. Positive 4bx sine 2x. You can cancel this one because you have minus 4bx sine 2x here. So what will remain in the left member of the equation is 4b cosine 2x minus 4a sine 2x, okay, equal to this right member of the equation. The next step is to equate the coefficients. Coefficient of cosine 2x is 4b in the right member of the equation, so you have positive 2. And for the coefficient of sine 2x, so you have minus 4a the right member of the equation, so you have positive 3. That's why your b is equal to 2 over 4 or 1 half, and your a is equal to negative 3 over 4. And your particular solution, or y sub b, then is minus 3 over 4 x cosine 2x plus 1 half x sine 2x. Therefore, your y sub c, your general solution is, of course, your y sub c is c sub 1 cosine 2x plus c sub 2 sine 2x minus the value of this one, okay, minus 3 over 4 x cosine 2x plus 1 half x sine 2x. This is the value of the y sub b. This is now your general solution.